Okay, welcome back to another Physical Sciences 3 lecture. We started off drawing in these the Lewis dot diagrams, or the dot diagrams for um, different different elements. So we started off with sulfur, and that was in group 6. So it had 6 valence electrons, which is how we draw it here. And so we have two paired electrons, two sets of pairs electrons, and we've got two unpaired electrons, which means that we can have two bonds formed from them. So if we look at our formula sheet again, we find carbon is in group 4. So it's really important that you do remember your Roman numerals, group 4. So that's group 4. And if we draw in our 4 unpaired, this implies that there is 4 bonds available. Okay, because there are 4 unbonded electrons. Bromine, if we look at bromine, bromine is in group 7. Okay, group 7 here. Okay, there we go. It's nicer, group 7. Good. So it's VII. And so if we went through and first of all draw in our 4 unpaired electrons, and then we've got 3 more. So 1, 2, and I'm going to draw this one, 3. It doesn't really matter where you put the unpaired electron there, but we can say 1 bond available. And phosphorus, finally phosphorus, we'll go have a look at phosphorus, which is in group 5. Okay, so 1, 2, 3, 4, and we can put the 5th one at the top there. So it's got 3 bonds available. Okay. Covalent molecular bonding. So the process of combining atoms sharing electrons so as to achieve stable octets of electrons results in the formation of covalent molecules. This section deals with the formation of covalent molecular substances. Consider the compound formed between two non-metallic elements, phosphorus and chlorine. What will be the chemical formula of the compound formed? We use the electron dot method to find the answer. So phosphorus can be represented as we saw before, P. Let's represent it this way with our 5 electrons on the outside. Okay, 5 valence electrons, and chlorine represented as, we can do it this way, Cl, it's similar to bromine, has 7 valence electrons, okay, so we can represent it like this. So I'm just trying to draw my circles in, it's not really nice on the screen. Hopefully you can see that. And it doesn't really matter where we position these, so this is the same as chlorine if we wanted to have 1 up the top here and 6 here, or even on the side, or on the other side as well. It doesn't matter where you put that solo one. These atoms thus combine by a way of sharing unpaired valence electrons. This means that 3 chlorine atoms will share with 1 phosphorus atom as shown below. So so we have 6, 7 of the chlorine pair with 1 of the unbonded ones up here, and then we do that 3 times. Okay, so all of these share electrons, and if you count up the electrons around each circle, you can see that there's 8 around this chlorine one. This chlorine one has 8 as well. This chlorine one has 8 around it, and this phosphorus also in the middle here has 8 around there as well. Another way that we can represent them, but if you're asked to do a Lewis dot diagram, then you need to do all the electrons. But if you can also show it this way. This implies that there's 1 pair of shared electrons. Okay, here, here, and here. Okay, 1 bond between them. This is a covalent molecular substance in which the molecules of 4 atoms are held together by 3 single covalent bonds. The left-hand diagram is called Lewis dot diagram. On the right-hand side, right-hand diagram, each covalent bond is indicated with a dash. So on this one, each is a dash. And in Physical Sciences 3, like I said, we use the dot diagram. Where 2 pairs of electrons are shared between the same atoms, it results in the formation of a double covalent bond. Okay, and these are stronger than single ones. So, for example, consider oxygen gas O2. We have these 2 atoms here, and then they combine here. So this these two unpaired electrons, they form in the center there to become pairs and have the 8 electrons around the outside. We can also represent it with the 2 lines shown here like that. Similarly, if we have nitrogen gas, which is also N2, this one although has 5 valence electrons, so it can form 3 bonds. Each of them form 3 bonds there, and they form in the middle here like that. Okay, so they're our pairs there. Okay, note that O2 and N2 are both examples of diatomic molecules. So di equals 2. So diatomic is equal to 2 atoms. Another term you might come across is polyatomic. And poly equals many. So polyatomic equals many atoms. Okay, so they might be some terms you might come across. And we'll have a look more closely at Lewis dot diagrams in the next lecture.